but now I am connecting, and will start within no time. Mm, Okay, so entire screen. Let me share the screen. Okay. Hello. Am I audible? Hello.
Yes, sir.
Yes, sir.
And I have shared the screen also. I think I'm available to all of you on screen also. Yes? Anybody having any problem?
No,
No,
sir.
sir.
Oh, yes. Okay. So let us. Yeah, somebody is having sound. Please unmute yourself so that I don't hear the rebound. Okay. Uh, Let me minimize and let me open the drawing. So this is the drawing that we will be looking. And it is ground beam column strap beam foundation. Let me open it. First, I'm opening the AutoCAD drawing so that we'll see the construction of a strap beam, because today we will be going for a strap beam, how to generate the strap beam in this. Uh, okay, you can see this. Uh, yes, is it visible to all of you? Hello.
Yes, sir.
Yeah,
Yes, sir.
you can see here is one footing, and one column over here, which is 230 by 450, and another column which is 300 by 450. So the two columns, and now unfortunately this column we do not have any offset on this side, because this could be the edge of the boundary. So we are having only a projection of, say, 0.27 from the center of the column. So if you see that, uh, if I measure this, so it is only 0.15. Okay, so we are having this is a practical limitation due to the plot boundary, and that's why you cannot have isolated footing over here, and that's why this footing of this column is to be connected to inside column, which is from the center of column. It is having a 3.45 meter or 11 feet 4 inches, the center. So the center to center distance between the two columns is 3.45. The size of this column is 230 450, 300 450. And now you can see the loading that I am considering is consisting for column 1. So this is column 1, which is having dead load as 350, live load as 200, and total it will be 550. For column 2, the dead load is 500, live load is 300, and total is 800. So together 800 plus 550, and all this is a working load. Okay, so it's not a ultimate load. So it is a working load that has been found with the analysis. And you can see the SBC for this area is available, is something around 250 kilonewton per square meter. And based on that, you can find out the soil subgrade modulus, which is 250 multiplied by 3, which is a factor of safety, divided by 25 which is the allowable settlement. So that comes out to be 30,000 kilonewton per cubic meter. Is this much clear?
Yes, sir.
Hello.
Yes,
Now,
sir.
Based on this 550 total load, you can find out the approximate area of footing that is required under this. And the only case is that the projection on the left side is 0.15 and remaining projection will be on right side. So I have considered 1.6 by 2 meter as the size of footing, and for this footing, you can see that the size considered is 1.8 by 2.3. Later on, you may change as per your choice if you find this is much greater. So this is a trial and error basis. Okay,
Yes, sir.
clear?
Yes, sir.
Now you can see the some detailing that I'm showing you. Detailing of strap footing will be something like this. So this yellow will be size of footing, this yellow, and it is connected by this magenta colored, which is a beam. Okay, so if you see the plan, in plan you will find a beam from this column edge to this column edge. uh, so the beam connecting to the two columns is to the, having 600 width. Okay, and you can consider depth of the beam initially as depth of the footing, and you can see that depth of footing that we are considering right now as zero point 0.6. Later on, based on our analysis, we may revise it. Clear? So this is the preliminary thing that you have to go through some trial and error, and or you can provide any size and later on you can change it. Clear? Hello.
Yes, sir.
Now, after that,
Yeah.
this as I have converted over here as this is a size of column, this is size of footing, this is another size of column and size of footing, and this is to be provided as a DXF file. Okay, so after creating this AutoCAD drawing, you can save this entire area as a DXF file. So that DXF file has already also I have prepared, and let me show you. So this is a DXF file. If I open that DXF file, you will see this. I think you people have no problem to create the DXF file, or anybody having a problem how to create the DXF file. Hello,
No, sir. No problem.
you can create the DXF file.
Yes,
So
sir.
I am just showing you the DXF file. So this is a DXF file. Now this DXF file we will import in our drawing in our SAFE, so that we don't have to define this size of column and size of footing. Clear?
Clear, sir.
Okay. Then let me close this, or okay, we'll minimize this. Instead of closing, we'll minimize this and we'll go to our SAFE. Okay, now you know the data. So you are having two columns with two footing sizes, and the arrangement of that footing size, and the center to center distance between the two columns, and loading on that column. So after that, you can double click on your SAFE. So SAFE 2016. And always one more thing, that always whenever you will save the DXF file, try to save the DXF file in the lower version than your whatever SAFE version that now you are having. SAFE version of 2016. You may be having higher version, but let's say that everybody is having 2016 version. Then you have to save that DXF file in lower version of AutoCAD than 2016. So you may save it in 2007, 13, 15, but not more than 16. Clear?
Yes, sir.
Okay. Now just click this. Then you can go to file. Okay. New model. And in new model, as whatever we have done previously, will go for that. Then units will go for metric units. Okay, design preferences you may check. So the design preferences are also there, and minimum cover for slab. But this is again, this slab is for footing, so we'll be using cover of the footing as 50. Then here you may provide bar size as 20 or anything you like. Okay. Then yeah, well, I forgot one more thing. Uh, that the units that for the DXF file must be in meters. Otherwise, or whatever units you are having for the DXF file, same units you should use over here. But right now, here we are using units of meter. Create the DXF file in units of meter and save it, and then you can go ahead. Now here, you can click on the blank. So I'm clicking on the blank. So after this, you can go to file, and instead of starting with new, you can go to import and see that in import, you have to go to this architectural plan or .dxf file. Click on this, then it will direct you to that DXF file. So go for that wherever you have provided. Now here I have provided that strap beam foundation DXF. So this is the drawing that I want to open, and I will click on that, and I will click on open. Now check the units here. CAD units are in meters. So I will go for units as meter. Then this is 0, 0, rotation 0, and scale factor 1. Rest of the things, center line, and click OK. So if you click OK, you will, why you're not getting it? You should, okay. Is there something wrong? 1 minute. Let me do it again. File, import, and then architectural plan. And let me see the, okay, here I will go for that. Then more strap beam and open and meters and open. Cannot open file Borostra beam foundation dot open. Then there is some error in that file, so we have to see it. Okay, we'll see that file. Uh, yeah, it was opened over here. That's why he was not. Yeah, that is okay. Go to that new model. Then
सर
yes.
सर थोड़ा मुझे मेडिकल हॉस्पिटल जाना होगा, इसलिए मैं क्लास छोड़ रहा हूँ.
Okay, okay. You can see the recorded session. No problem.
ओके सर.
Yeah, no problem. Okay. Okay, then import DXF file, and then this, and open. Yes, open. That was opened over there, and that's why we were not getting it. You can see the file is there now. Restore down and go for that. See, this is the drawing. Let me see the dimensions. Some dimensional error is there, huh? Actually, it's not
Yes, sir.
in
You have
meter.
not selected the CAD drawing in meters. It was in inches.
Uh, okay, then let me close this. Something was wrong there. Okay. We have to see the CAD drawing first. Okay, I'm closing this. Am I audible?
Yes, sir.
Yeah, today some problems are coming. I was disconnected. I don't know why. Uh, okay. Let me present first. Okay, all of you can see this. Hello.
Yes,
Yes,
sir.
sir.
I was disconnected. Unfortunately, I was not knowing what is happening, but I was disconnected.
एक्चुअल में सर आपने गलती से टैब क्लोज कर दिया था सर वो
Yes.
एक्चुअल में आपने सर गलती से टैब क्लोज कर दिया था सर जो स्क्रीन का है ना
हाँ,
वो सर ड्राइंग को क्लोज करने के चक्कर
अच्छा
मिनिमाइज या
वो
क्लोज करने
नेट ही डिस्कनेक्ट हुआ था. ओके
यस सर
या ठीक है. Let me see that. See, actually, that import some mistake I have done in that importing this actually, but we can draw it from our basic principles also, because right now I don't have time to check what is going wrong. So we'll concentrate on this. So how we can easily create the drawing also. I was just trying to show that it can be imported through the AutoCAD drawings. But okay, we'll use this manually, and we'll go into that. Okay, so I will minimize. Okay. So we are going for this file. We'll open new model. New model. We'll go for IS456. Design preferences are same, and units are currently, and I'm clicking on blank. Okay. Now in blank, first we'll try to define our material. So the same process. So I'm just going, so here now, instead of creating a new material, I will modify the existing properties. So this is for concrete. So I will modify it. So with this as M25. Okay. The material type will be concrete. Here you will provide specific weight, which is 25, and here you will provide modulus of elasticity, which is 5,000 into square root of 25, which is again 5, and I will enter. So it is 25,000, and this you can keep, and here you will provide 25 and click OK. Okay, so the material concrete grade M25, and this is the grade of steel. So we'll modify that also, and here we'll provide it as HYSD 500. So I'm providing 500. So the type will be rebar, and here the specific weight will be 78.5, and modulus of elasticity 2 into 10 raised to 5, and this will be 500, and this FU will be 545. Okay, so the materials are defined. Then you will define the property for slab. So here add new property. I will say a property for footing. Okay, then concrete material will be concrete. This will be footing, and this will be let's say we'll start with 600. So depth of footing or thickness of footing will be 600 thick plate, Okay, the same you can go for add copy of property, or you can go for add new property here, or column. So column. Okay, so the property of column will be concrete will be M25, and thickness will be something around 600, and design type or analysis data type will be steep and thick plate, and click OK, and click OK. So the material is defined. Now we have to create this, which actually we wanted to export, but now we'll create the first this center point will be created, and then this center point will be created. So the distance between the center point is 3.45. So let us go and create. So draw, and in that draw point. So where draw point, and this will be, let's say I will draw it over here. Okay, so the point that you can see you have drawn it over here, and then uh, x dimension plan offset will be 3.45, because center distance between the two is this. And here I will click on this. Not 3.45, actually it is in, yeah, it is in meters. Let me cancel this. Delete. Okay, draw points. So the point will be, the object will be drawn wherever you will click it. Okay. Uh, okay, then I will highlight this. Go to this select object and select this, and go to edit and replicate, and in replicate I will use this 3.45 and linear, and delete original, no. So you can see um, let me see, draw points, draw dimension line from this point to this point. Actually we have drawn 2 points. Draw dimension line. 3.39. That means this point. Okay, this point is to be deleted. शायद आप लोग देख नहीं पा रहे होगे ना. हेलो, कैन यू सी दिस? हेलो.
Yes, sir.
So let me see again. Dimension line from this point to this point. Yeah, now it is again some units are missing, I think. We'll have to close and close it. चीजें आज वर्कआउट नहीं हो रही यार, क्या बात है?
कई बार हो जाता है सर।
हाँ, न्यू मॉडल नहीं, यहाँ पे हमने कुछ गड़बड़ किया है। यहाँ पे सी दिस इज 456, देन metric default, okay, then design preferences, okay, design preference are okay, then this okay, and okay, we can go for grid also. So grid, what I will say, in x direction there will be 2 lines, in y direction there will be 2 lines, then spacing, let's say 3.45, and in y direction let's say 1. So we'll create that. Okay, now we can see that a distance, so we are having one grid point over here, another grid point over here, and if you see the distance, where is dimension line? Yes, now it is 3.45. Okay, so we'll take help of these grid lines, so that instead of going blank, we are having one reference point over here, another reference point over here. So this grid line you may have access. So just draw, then draw points, and click one point over here, another point over here. Okay, so the points have been clicked. Now here will provide the size, so 1.6 by 2.2 meter. Okay, and then 1.8 by 2.3. Okay, so 1.6 by 2 meter. So here we'll provide that, but before that, define the materials, because again we'll have to do it fast. So M25, this will be 25 concrete, and this will be 25,000, and this will be 25. Okay, then this modify HYST 500, rebar 78.5, and 2000. Okay, this will be 500, and this will be 545. Okay, the material has been defined. Then we'll define slab properties. So add new property. This will be footing, and M25. This will be footing. This, let us say, we'll start with 500, and we'll see that whether it is sufficient, then we'll increase. Okay, then add new property. Then this will be for column. ULUM column 25. This will be steep, and this will be 500. Right? यहाँ तक हम लोग सही है. So that has been also defined. So we'll draw footing over here. We'll draw another footing over here. So this footing will be 1.6 by, what is that? 1.6 by 2 meter. Okay, so go to the draw and quick draw area around. So click on that, and here the area will be type will be footing, and area will be 1.6 by 2 meter. Clear? So X dimension is 1.6, Y dimension is 2 meter, and you will have to click on this. Okay, then another dimension is 1.8 by 2.3. So this will be 1.8 by 2.3. And you will click on this. Okay. Okay, again, we'll draw a column over here. The first, we'll have to create a distance, a point over here, so that you can go for that. And here, you will have that distance. So you can check it. So how much is the distance? 0.27. So from this midpoint, the distance is 0.27. And here it will be a center point. Yes? Are you getting it? Hello?
Yes.
Yes, sir.
Yes, sir.
So the first you have to create a point. So draw points 0, 0, and here the offset distance will be 0.27. 0.27. That will be this, and Y will be at center. So I will click this midpoint so that I'm having exact point where I want to draw the column. So I will draw a column over here and a column over here. Okay, then again you will go to draw, quick draw areas. So quick draw areas around points, and then here it will be column. A property will be column. And dimension will be 0.23. Dimension will be 0.23. Y dimension will be 0.45. Right? You can check that in your drawing. So 230 by 450 is the column, that is you have to draw it over here, and 300 by 450 is the column, you have to draw it over here. So click this point. Clear. We have to, yes. Okay. Now the point is drawn. Now here it will be 0.3. And the dimension, it will be over here. And then close this, go to this. Okay. So this is the initial sizing that you have assumed, and we have to check it through the data. So now what are the things that you must provide? The first thing is that you have to provide a soil subgrade modulus to this footing and this footing. Okay. And then you have to provide these loads 350, 200, 500, 300 on this footing and this footing. Clear? Okay. So define the soil subgrade modulus. You can check it over here, modify. So I will call it as 250, because 250 is our soil bearing capacity, and here it will be 250 multiplied by 300, I mean 3 divided by 0.025 and enter. So 30,000. Directly you can provide 30,000, or you can use this way. So the soil property has been defined. Then select this footing. go to assign, support data, soil property, and assign the soil property. Then select this footing, go to assign, soil data, soil properties, and 250, click OK. So that has been drawn. Okay, now you will have to provide the loading on this footing and this footing. Let us go
सर
and
वो फुटिंग को भी शिफ्ट करना पड़ेगा ना, ए वाला
which one?
जो सेंटर टू सेंटर डिस्टेंस 3.45 है ना कॉलम के सेंटर से.
We'll have to check that what has done. Okay. From this point, actually it is clicking another point. Yes, I think we have drawn it from this point to this point.
Yes sir.
Yeah, that means we have to shift the entire thing from this point to this point. Okay, so
Yes.
select this footing, then select this. So the two areas have been selected, and go to edit, and in edit you have to see move points, line and areas. Click on that, and here you will have to measure from this point to this point, whatever is there. कैसे होगा पहले चेक करना पड़ेगा, क्योंकि यहाँ पे वो फैसिलिटी नहीं है. राइट. सो क्या करेंगे, पहले चेक करते हैं. ओके, गो टू दैट draw dimension line, and from this point to this point, so it is 0.53. Okay, so you have to shift by 0.53 the column as well as footing. So you can check that two areas and 8 edges have selected. Go to edit, go to move points, and here x will be equal to it will be 0.53, and click OK. So this is how it is. So if I see this now, draw dimension line, and from this point to this point, yes, 3.45. Now it is correct, I think. Yes.
Yes sir.
Yes,
Yeah.
sir.
So you can select this point, go to this, select this point, end of grid line, this point, and delete. That is a grid point end. That's why it is catching that. Okay. Okay, now this is one point, this is another point where you have to provide the loading. But before that, you can check the load patterns. So dead and live are there with 1, 1. Okay, then you can create, go to define, load combinations, and add new combination. You can provide this as combination 1, and here you will provide it as live and service normal. So this will be our live load condition. Then add new combination 2. Then this will be dead load, and this will be live load, and it will be 1.5 and 1.5, and strength Then okay, now I will select this point and I will provide the data 350 and 200 and size is 230 by 450. Okay, so go to assign. Now assign load data. Under load data, go to point loads. So under dead load, how much it was? 300. Let me check it. 350 and 200. Okay, so it will be 350 and replace, and dimension will be 230 by 450. So this is the dimension. Then again, select, go to assign, clear display of assign, and select the point, assign load data, point load, and under live load category, it will be 200 and size will be same. Replace. Okay. So go to assign, clear display of assign. Okay, I will select this. So go to select this, and the loading. What is the loading? 500 and 300, and size is 300 by 450. So under that, go to assign load data, point load. Under dead load, it will be 500. Size will be 300. Replace. Okay. Then assign, clear display of assign. Select. Then assign load data, point load, and it will be under live load category. It will be 300. Replace. Okay. Okay. So if I click on that and right click and check it under loads, okay, 350 and 200. So the loads are assigned. Under this, loads 500 and 300 are assigned. Okay, then you will have to go to run analysis. So it will ask you to save it somewhere. So Strap Beam Foundation, and I will save it under our normal category. What is that? Under this, we have SAP tutorials. The SAP tutorials, design strap beam foundation .fdb file. So save the file. Okay. Now you can check. The first thing is that what you will check: display, show deform shape. Under that, load combination number 1, which is dead load plus live load. Apply, close, and see, this is 14. Highest is 16. Even this color is not appearing over here, or you can check it like this. So highest you are getting 15 mm. And what is allowable? Yes. हेलो, अरे आप लोग
Yes,
है
sir.
कि नहीं वहां पे?
Yes, sir.
तो आंसर नहीं कर रहे हैं. So what is the allowable that settlement that
25 mm.
yeah,
25 mm. 25 mm.
25, and what we are getting something
16
around
mm.
16. So it is
15.
well within the limits. So the next case is that we have to see whether we can have that another thing is that soil pressure. So show reaction forces. Under show reaction forces, you have to go for load combination, combination number one, which is working load combination, and apply and close and check. Now here is the catch. So how much you are getting? 450. Hello. You can check it over here. So it is something around 464. So 450. If you see the color, this is the color. That means something around 450. And what is the allowable soil pressure that we are getting? See, this footing we don't have any problem because this footing is colored with this, which is less than 250. You can check it. It is everywhere. It is less than 250. So here we don't have a problem. But here we are having a problem, which is going from this. So this color is 221. But as you go towards the column, you are getting this. And what is the reason for that? Anybody?
उधर offset कम है
Eccentric
इसके
load.
अंदर।
Yeah. See, because of this, see, this is the
Eccentric.
loaded area, and this loaded area does not have a footing on this side. That's why here it is getting excessive pressure, and which is excessive than your
Soil bearing
self-bearing capacity. And that's why either see will try to increase the size of footing, so that instead of that, right now we are somewhere at say 485, or say you can say 450, and allowable is 250. So we can increase this size of footing on this side and this side. Okay, or you can increase on this side also, because increasing on this side is not allowed because it is restricted. So you can increase the footing on three sides. Let's say we'll try to increase it in this side by 0.15 and this side by 0.15, or let's say by 0.3 on this side and 0.3 on this side. Clear? Hello.
Yes, sir.
Yes, sir.
Okay, then unlock it. Now I want to increase the footing on this side and on this side. So I will go first, draw the points, and here on Y dimension, I will provide 0.3. Okay, and I will click on this point, and I will click on this point, and here now I will provide Y dimension as minus, what is that, minus 0.3, so that I will have a point downside. Okay, I can also increase the footing on this side, but I am not interested. Let us increase the footing on this side, and again reanalyze and see whether that bearing pressure is getting down or it does not have any effect. Okay, now after that you can go to reshape. So this is your reshape object, and select it and move this point to this point, this point to this point, this point to this point, and this point to this point. Okay. Yes. So we had one attempt that whether something happens by increasing the size of the footing on this side and this side. So again, run analysis and design, or only analysis, and see the display, reaction forces, soil pressure, combination 1, apply and close, and see that. Now you can check it something around, this is something around 362, right? So a little bit effect, you can check it over here also. This is something around 360. So this is uh, 362 or 60. You can, as you go on this side, you're getting pressure less. Now this, you cannot increase this footing on this side and this side uh, with a large area, because in that case, then bending moment under the footing will be excessive, and you will have to provide more and more reinforcement and bottom, and even then also it may not be suitable. So what we are trying to do that this bearing capacity or bearing pressure exceeded in this area, will try to make compromise with creating a beam over here, so that that beam, that is called a strap beam. So if you go into this, so this is your strap beam. This strap beam tries to reduce the bearing pressure on the footing, and it connects this column and transfers the load from this column to this column with bending moment. So in middle part there will be more hogging moment, and that you can see after analyze. So we'll try to judge that. Okay, now we have to create a beam from this point to this point. Okay, and for that you have to create the size of beam first. So just go to define and go to beam properties, and under beam properties go for add new property. Now this is a little bit new to you, so try to check it. Shall I repeat it again? Yes. See, I want to draw a beam from this point to this point. Okay. Either I can draw a beam from this point to this point, but as in this footing, I don't have any problem. The bearing capacity is lesser. I mean, bearing pressure is less than the bearing capacity available over here. The only problem is over here, and that's why we are trying to transfer a load from this point to this point through a beam. Yes, are you getting this concept? Hello.
Yes, sir.
Okay, so for that we have to draw a beam, and again, whatever you have to draw, you have to define first. So we are defining that beam. So go to beam properties, and in beam properties go to add new property. Under this add new property, you can use the name. So the name of the beam, let's say size of the beam. I will assume the size of beam as uh, more than the depth of the column. So let's say I'm having a width of the beam as 600 by depth of the beam as we are going for that 500. Okay, we have to see that one check also before that. I forgotten that. So we have to analyze, and we have to see what is happening with that punching shear. So we have not checked that. Okay, so we'll go to display, and we'll have to go for show punching shear. You can see punching shear is no problem over here, right? So I can minimize the depth of the beam with respect to depth of the footing. So depth of the footing that we have considered is 500, right? See, if had it been the case that we are getting a punching shear more than one, that means then we have to check for the shear forces also, and in that case you need a depth of the beam more than the depth of the footing. But right now that 500 depth is more than enough, because itself it is capable of transferring the shear forces. So we'll go for depth of the beam as 500 only. Okay, so you can go for 450 by 500, or you can go for 600. See, why we are going for a bigger dimension width of the strap beam? Because strap beam will have bars in this direction, which will be interfering the bars of the columns. That's why we are having a wider beam. Okay, so I will say that you can go for 600 by 500. Clear? Yes. So go to that beam properties. Under beam properties, go for that. So I will have that 600 by 500, because 500 is the depth of footing. Then here you can see width, web width at top. That means what is the width at top? So width at top is 600, and you can see the change in the size. Then width at the bottom, you can have lesser width, but right now we are having that. And depth of the beam, that we are going for 500. Okay, is this much clear how we have defined? See, the first you have to see that width of the beam is more than depth of the beam. Otherwise, the vertical bars of column and horizontal bar, longitudinal bars of beam might get intersecting each other, crossing each other. So the arrangement will be difficult to place. Okay, clear?
Yes, sir.
Now you can check it over here. Cover top to centroid. So cover top cover of the beam. Now this beam is not a beam which you are considering at slab level. This is at a footing level. So the minimum clear cover for the beam at top has to be 50. Then plus. Now I am going to use the stirrups not less than 10. So the stirrup size plus okay, plus now half the diameter of the top bar. Now top bars for the strap beam will be always main bars, because the strap beam will have always a hogging bending moment. So on the top, you will have a larger diameter of the longitudinal bars. Let's say I'm going to use 20. So half of 20 will be 10. And so something is wrong over here. So the first is 50 plus 10 dia, because I am using 10 dia stirrups, plus half of 20, which is 10. And okay, so that is 70. Similarly, here also it will be, but here you will have a lesser, because at the bottom you may not need a 20 dia bars for the strap beam. Let's say you are going to use 12 dia bars. So in that case, you will say that bottom reinforcement clear cover will be 50 plus 10 plus 6. So this is 66. Now you may say that 70 is also good, or 75 is also good, but I have just shown you this detailing, because this is the practically how we consider the cover to centroid. So the effective cover. So what we call it as effective cover. and then you can say okay and okay. Now you have defined the beam. Now you have to draw the beam. How you draw beam? Now here the beam will be 600 by 500. You can check it, straight line, and then I will draw a beam from this point to this point and enter and close. Now you see only a line. If you want to see that in 3 dimension, uh, okay, let me go to that, and you can see extrude areas. So here extrude view, you check it on extrude view and click OK. You can see this is how you are having a strap beam. Clear?
Yes, sir.
Okay. Then again I will remove that. And now let us see whether it has done any effect on that or not. So whether we have whatever strap beam that we have added, has the strap beam made any effect, or whatever results we were getting, we are getting the same results. So go to run analysis and design, and now you can see. Okay, first let us see the reaction forces. Soil, apply and close. Now you can check it. So here you can see. So now maximum here, which is this color, which is somewhere, it's actually that color is not appearing anywhere. So you can see that red color maximum, or you can check it over here. So you're getting now the soil pressure as 192. Clear?
Yes, sir.
And you can check it over here. And here also it is 199. So that is the exact use of strap beam. So initially for the same things, individual footing was not able to sustain the vertical loads, but after attaching a beam, a strap beam, or this column has been attached to internal column, because very clear is that the a load from outer beam is transferred on a load on the inner column. I mean, load from outer column is transferred on the inner column via the connection of the beam. That's why it is called a strap beam. Okay, clear? Any doubt
Yes, sir.
into this? See, try to think conceptually on this, why the beam is appearing. Because if you have your conceptual idea clear, there will be no misunderstanding while you are going for detailing, whether the bottom bar should be more or top bar should be more, whether this now this footing, why this footing is now having allowable is subjected to lesser uh, upward load, because now the um, entire load has been considered by one column, another column, and this beam, and this part is coming will be just like a cantilever, upside cantilever. You can check it over here. So it can be considered as upside cantilever. So this part of the footing, or let's say this part of the footing is considered as just subjected to lesser upward pressure. Clear? Yes, any doubt? Hello? अरे आप लोग बात नहीं कर रहे हैं.
Clear, sir.
Yes. I think now you can understand how this can be done. Now it's a time for design. Okay, the arrangement has been finalized. Column size is already you have defined. Now for corresponding column with restricted projection, you have defined the size of the footing for outer column, for inner column. Depth of the footing is also defined. Now it is the time for reinforcement. And then what we have to do? Unlock first, then normally you have to go for uh, strip forces. So unless you provide section cut or design strips, this software SEF cannot give you the results about shear force and bending moment diagram. Now, if I ask him for shear force and bending moment diagram, he will not be in a position, because he will ask you where you want, what is the section. Now, that section is defined through your design strips. And how you will draw the design strips? Just by going into this, go to design, draw design strips, and these are the this. Now here you can provide parallel strips in this direction as well as parallel strips in this direction with some this thing. Now let's say I may draw a strip from this point to this point as only one strip, then another strip from this point to this point, and one more strip from this point to this point with some arbitrary column strip dimensions. And what could be the strips for that? Uh, okay, just check the dimension. So go to draw dimension line, and from this point to this point. So it is now 2.6. Okay, so you may go for a strip which is having uh, 2.6 divided by 4. So what will be that? 1.3, 1.4, so 0.75. So you may go for zero point 0.8 on this side, zero point 0.8 on this side with this central strip only, and that will give you the reinforcement that you are getting into the beam. And another strip you may go for this, or you may have parallel strips on this line, or you may have parallel strips all along the putty. So the best way is you can go for design strip as, let's say I will go for 0 0.8. There is no hard and fast rule that what should be the uh, width of the strip. The main function for this drawing strip is to get the bending moment and shear force diagram across any section. So where you will get, let's say I want to have the bending moment and shear force diagram in the horizontal X direction, then I must have a strip from this point to this point. Yes, yes or no?
Yes, sir.
Yeah. Similarly, maximum reinforcement will be under the column strip, and there will be minimum reinforcement in this strip, which is exposed to this. But you may go for number of strips more. So in that case, let's say if I check the distance, so it is 1.6. So I may have number of strips in this line. So let's say I will draw one strip from, what, something is wrong. Let me go and draw it again. Okay, the strip is drawn. Draw draw design strip. Now I want it in this direction. So I may start with this point or on this point. Enter. Then I may draw it from this point to this point. Enter. And if you want additional strips on this, you can select them. Let's say you can select, actually it is not drawn correctly. Well, enter and delete. And this is, yeah, this is drawn correctly. So we'll draw it again. Let's say we'll check out the point. Okay, draw design strip in B direction. I will draw it from this point. Okay. Okay. Okay, we have drawn that section line, and now we can go with analysis and design. Okay, then go to display. Now you know how you can find the strip forces, slab forces, show slab design. So we'll first go for show beam design. Under that, you can go for longitudinal rebar, enveloping, then impose minimum. So you can click on this and you can apply and close. And now you can check the maximum reinforcement also. Here you are getting top reinforcement at this point. You are getting 1676. Okay. So if you are using 20 dia bar, so you will need 1676 divided by 314. Let me have the calculator. 1 minute. So how much it will be? Hello. Yes. Anybody?
5.33.
5.33. Okay. So 5.33 means you need
Yes, sir.
6 bars. Now these 6 bars you have to provide at top. And now if you see your diagram, so you can check that 600. So in 600 you cannot provide 6 bars. That means you have to provide let's say if I draw it a beam something like this, we provide rectangle. If I provide, let's say it is something like this, then you can provide 4 bars in the top layer and 2 additional bars in the bottom layer. So in 2 layers you will provide that reinforcement. Yes, you can see 1676 on this side. Here it is lesser, so we'll provide 1676 6 bars. So let us do that and see whether that is sufficient, and that is at the top. And what is at the bottom? You can see at bottom here, you need 0. As you go on this, you will see that at bottom, you do not need any reinforcement at all. You can check it. But here you need something 368. So let us provide 4 bars of 12 dia bar at bottom. Right? Hello.
Okay.
Yes.
Okay, sir.
Yeah. So what we are going to provide? So go into that display in show beam design. Under beam design, we are getting okay. So go to close and now display. Show beam forces where you will provide it. So beam design display. So slab design named beam forces and stresses. Slab. Yeah, under this only you have to provide show values at controlling sections, scale factor, apply enveloping longitudinal bars, flexure and torsion. So enveloping will have this, but where you will provide that, I'm not getting it right now. Okay, one more thing. If we go for transverse footing, so let us provide that also. Display, show strip forces, show slab design. Under that slab design, okay, show, okay, first layer A, then none, show total rebar area, okay, and you can apply and close, and you can see for the slab, you will see that this top is 79. So for slab, you don't need much reinforcement at top, and bottom you need 108 in this part, and if you go on this part, you need something 00. So 13 7 740 651 673. So this is longitudinal reinforcement. So at this point, $753. I think something is getting okay, but right now it is 9 o'clock. Okay, we'll proceed with this in the next session, but you can check it something like this. So top here also, you don't need any reinforcement at top. You need a reinforcement at this as 343. Here you need at bottom 527. And in this, you don't need at all a reinforcement. 140. So let us provide this reinforcement everywhere. So 199 at bottom. So if you go and provide that, show slab design. Okay. Now here you will go for typical, and here top reinforcement you may go for 10 because you don't need a reinforcement at that. Bottom reinforcement you can go for even you can go for 250, 250. Let's say 200 at top and 200 at bottom. And if you provide that, you will see now you don't need at all a reinforcement. Either you will have to go for additional strips, because here you can check it here. Actually, this is a reinforcement for beam, and that you can see that at top you need a reinforcement. So that is at top, and that is of the beam. So you have to provide a strip on this line also, so that it will give you the reinforcement. But that will check, no problem. I think we'll have this much for today. Yes, Samir. Hello.
Yes, sir.
Anything that finally you can see that only in this direction, footing at top, for this footing you need a reinforcement at bottom and top, and only in this beam you need a reinforcement at bottom and at top. Even then, at bottom it will be very less. Most of the time 12 bars of 4 numbers of 12 bars, or you may say 4 numbers of 16 bars, depending on the length of the beam. But top, you have to provide 20 dia bars with 6 numbers. Okay.
Yes, sir.
Hello. Okay. So if you have any query, you may please ask me, or I will also check with that detailing, and I will try to provide detailing in tomorrow's session. Right? I think tomorrow we are having consecutive sessions. So day after tomorrow, no. Actually, tomorrow there will be a session, and I don't know, day after tomorrow there will be a session. Most of the time there will be a session. Continuous 3 sessions will be there. But that is up to you. If you people need 1 day break, we can have tomorrow break, and day after tomorrow we can continue. Yes. Anything? Hello.
We don't have
Samir,
any problem.
नहीं वो
If the
थोड़ा
class continue consecutive days, it will not be a problem.
okay, then we'll continue tomorrow also, no problem. Tomorrow we'll finish whatever left in this session, and then we'll go for mat foundation. I will also
Yes.
see why I was not getting that import facility, because something will be there, that unit conversion was not properly done by me. But I will do that, and will import that drawing. So this drawing, I want to say this drawing. We'll create this drawing in AutoCAD, and then we'll have a DXF file with a meter unit, and then we'll import this drawing, and we'll see that how within one minute how we can create everything. That is what we have created manually. So we have created one point over here, another point over here. Then with this point, we have created a slab on this side, on this side. Then we have also created a column. So all that can be done in one step just by importing. Uh, some error was there in the file, and that's why I could not import. But we'll see that. I will check that error, and tomorrow we'll import that, and with the same thing, we'll go for detailing of this strap putting, and then immediately we'll start with mat foundation. Okay.
Yes, sir.
Yeah. So with this, we'll conclude today's session, and let us look for tomorrow's session for mat foundation also. Thank you.
Thank you, sir. Good night.
Good night.
Good night, sir.
Good night.
Thank you, sir. Good night, sir.
Good night. Good night.